Okay, so first thing I want you to write up here, similar to what I have up on the board, okay? Law of cosines, we are going to use if we have side, 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 so 3 side lengths, or we have side, angle, side. Okay, when we were doing law of sines, that would either be my side, side, angle, my angle, angle, side, or, I don't know why I put in parentheses there, or an angle, side, angle is when we use the law of sines there, okay? But for law of cosines, it's when we have 2 side lengths or more, and it's not the ambiguous case. We've got 3 formulas there. They're all very similar. The only difference is that they're changing the placement of the variables. So if I have a side length A that I'm trying to solve for, this is probably the equation you're going to use because your B and C and everything else is over on the other side. But you will have to be given an angle measure there, and a side length and an angle measure, or you'll have to be given all 3 side lengths in order to solve for this, okay? So very similar, just slightly different depending on what you're given for those 3 formulas, and you'll be given those on your formula sheet. So if I look at this first example here, we've got a surveyor wishing to find the distance between 2 points, A and B, opposite sides of a lake. While standing at point C, she finds that the length AC is 259, BC is equal to 423, and angle ACB measures 132 degrees and 40 minutes. So we need to find the distance AB. So if I look at this picture right here, AB, what side length would we call that? A, B, or C? Side length C, because it's across from angle C, okay? So if I'm finding C, looking at my formula right here, am I going to use formula 1, 2, or 3? 3. Yeah, because it's solved for C squared, right? So I'm going to plug in all my information that I know into this formula where A is equal to 423 and B is equal to 259, okay? So let's plug all that information in. I've got C squared is equal to my A value, which is 423 squared, plus 259 squared, plus, minus, using my formula, minus 2 times 423 times 259 cosine of 132 degrees and 40 minutes. I just plugged all that in from my formula up above, okay? Now, I would highly recommend you write this down on your test before you actually plug it in the calculator, because I was having quite a few people have issues on their calculator last period. So now we'll just type this whole thing in. I would type all of it in one fell swoop. Make sure you're using a minus sign here and not a negative, otherwise you will get the wrong answer. And also make sure you are in degree mode. If you are not in degree mode, it will also give you the wrong answer. But you should get approximately 394,510.5693. And then, yes, we do have to square root it, right? Because that's C squared. So to find C, I'm going to square root both sides. And I end up getting C is approximately 628.1 meters. All right, example 2, we're going to solve the triangle, which means we're going to solve for all the missing angles and all the missing side lengths that we don't have. And everything's already labeled on there. Okay, so similar to like on your previous homework when you were labeling triangles, if I was labeling what I'm given here, this triangle we have a side length and another side length, but the angle is in between. So technically this is a side angle side triangle, not side side angle, okay? The angle is included in between the 2 side lengths. So that's how we would label it, side angle side, and we're using cosine because cosine is when we have 2 sides and an angle in between. So I'm using law of cosines, and I'm going to start by solving for side length A. Which formula am I going to use to solve for side length A? the first one. So I'm going to plug in all my information. I've got a squared is equal to 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times cosine 42.3, and that should be all that. Again, just straight from the formula. Nothing too crazy, you just got to make sure you're plugging in the correct letters for the right numbers. So plug this into our calculator. And you should, after you square root both sides, end up with about 10.47 meters. So take a second and check on your calculator. That's what you get. Once I have an angle, we're good. Okay, so once I have a side, and I have all three now, I need to find the angle measures, okay? So if I was given side angle side, I need to find, excuse me, I'm going to write a note here. We're going to find the smallest angle first. When we have our side angle side, okay? Which means, where's my smallest angle going to be across from? Across from the smallest side, right? So always across the smallest side. Okay, so we already found A. A is equal to, oh my gosh, 10.47. So now, of the two remaining sides, B is smaller, so I'm going to find angle B, okay? And we're going to find it using law of sines, which we've already done from last class, okay? So then we can just write a little note here. Use law of sines to solve missing angles. Okay. So let's go ahead and set this up here. We've got sine of A, which is 42.3, divided by my side length of A, which is 10.47, is going to equal sine of B divided by 12.9. Now, if I solve for B, can I find C pretty easily? Yeah, by subtracting from 180. So from here, I don't need to set up my third proportion because I just want to solve for one of these missing angles. So let's go ahead and cross multiply here. That would give me 12.9 sine of 42.3 is equal to 10.47 sine of B. How do I get sine of B by itself? Divide by 10.47. So now to get the sine to go away on both sides, we have to do the sine inverse of all of that stuff to give me what B equals. So if you plug all that into your calculator, for B, you should end up getting, I think it's 56 degrees. Once I know that this is approximately 56 degrees, I can find C by taking 180 and subtracting those other two angles. So angle C is equal to 81.7. So those are my three pieces of information that were missing for my triangle. And so we are done, okay? Keep in mind, whenever we have the side angle side that we're given, we find the missing angle missing side length first using your law of cosines, and then choose the smaller of the two angles in order to find out your missing two angles using law of sines, okay? Because this next one that we're gonna do, it says solve the triangle given all three side lengths, okay? If we're given side, 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 we've got three different side lengths here, okay? We're gonna use law of cosines to find the missing angle measure. And then after we use law of cosines to find one of the missing angles, we can use law of cosines or we can use a different law to figure out the others. But I'm gonna go ahead and draw a picture here of a triangle, and label this information on here. I've got A, B, and C. Side length A is 9.47, B is 15.9, and C is 21.1. Okay, so if you go back and look at your formula sheet, I'm going to put the picture of our formula cosine of C, maybe. Okay. Okay, so this formula is on your formula sheet, okay? When you're given 3 side lengths, you have to solve for the largest angle first. Oops, make a little note. Given side, 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 find the largest angle first. Okay, my largest angle is going to be across from my largest side, right? So largest angle is going to be angle C, because across from angle C is 21.1. That's the biggest side length. So this formula right here is solved for the angle cosine of C. So I just have to plug in all my information. This is my C value, A value, and my B value. So let's go ahead and plug all that into my formula. I've got cosine of C, 21.1 squared minus 9.47 squared minus 15.9 squared divided by -2. And then last thing on there is B, so 15.9. Okay. Now, is this technically solving for C, or is this solving for cosine of C? That's solving for cosine of C, right? So if I want to solve for C, I'm going to have to take the inverse of whatever I get. So when you plug in the stuff on the right-hand side, you're going to get approximately -0.341094002. Okay, and if I want to solve for C, I'm going to take the inverse of both sides. So C is equal to the inverse of that stuff. So you should, again, this is kind of difficult on the calculator, but you should get approximately 109.9 degrees. So take a minute and plug all this in your calculator. Make sure you can get that answer. Being careful, especially here with this fraction. Highly recommend to use alpha y equals to make your fraction bar on your calculator. Now that we have C, we need to just find one other angle measure to, subtract from 180 so that way we can find the missing one. So after we have found the largest angle, we can either use cosine, law of cosines, to figure out the missing one, or we can use law of sines. Preferably, I like law of sines because there's less places I feel like to make mistakes when you're typing it all in the calculator. So we will finish off this problem with law of sine. So I'm going to do sine of angle A divided by side length A is equal to sine of C, which we know is 109.9, divided by 21.1. Because once I know one of these angle measures, I can find the other one very easily. So I can cross multiply here. And then if I want to get sine of A by itself, can divide by 21.1. And then if I want A by itself, I need to take the sine inverse of all that stuff. (24.96 degrees). So that's angle A. I know angle C. So if I want to find angle B, what is happening? I take 180 and I subtract both of these things. And I get 45.14 degrees. These formulas are also on your formula sheet, okay? These formulas are finding area of triangles that we don't know the height of, okay? But maybe we know all 3 side lengths, or maybe we know 2 side lengths and an angle, okay? So there's formulas for those based on what we're given, okay? So this guy named, I think you say Heron's formula, this guy named Heron from a long time ago came up with this formula where S is your semi-perimeter, okay? So you have basically the perimeter of your triangle divided by 2 is the semi-perimeter. And then to find the area of that triangle, you take the square root of whatever you get for the semi-perimeter and times the semi-perimeter with the difference of the side lengths times all 3. Okay? So, this is going to look really gross when we write it all down, but it's really just, again, plugging into the numbers on your calculator and just evaluating it. Because I can only use Pythagorean theorem with what kind of triangle? A right triangle, and we don't have a right triangle here in this picture, okay? So example 4, we're trying to find the distance between New York, Montreal, and Los Angeles. We're trying to find the area between all 3 of those things, okay? So we're going to start out by finding what the semi-perimeter is. So the semi-perimeter is 1/2 times all these things added together. So 2427 plus 2451 plus 331. And that should give you 2,604.5. Okay, now to find my area. Instead of writing S every single time, instead of writing this number every single time, I'm going to write S instead, because otherwise it's going to be super long there. So I've got the square root of my value S. Actually, I lied. I'm just going to write it down. I'll just write really small. 2,604.5 times 2,604.5 minus side length A, which was 2,451, times S again, minus my side length B, which is 331. And lastly, times S minus side length C, which is 2,427. Okay. That should be there. So now take a second, type all of this into your calculator. Make sure we all get the same answer. I think mine was wrong, actually, so I need to do it too. I got 401,664.1109. If we're talking about area, what are my units? Miles squared. And lastly, this one we're given a side included with an angle followed by another side length with these 3 formulas here to find my area. These are area formulas, hence why A equals, even though sometimes A stands for also my angle measure, right? So be careful there. These are my area formulas. So I just got to plug in my information. Am I going to use equation 1, 2, or 3 there if I'm solving to find my area? Equation 3, because I know A, C, and I know my angle B. So I'm going to use the third one there, plug in all my information, and then plug it in the calculator. So my area is 1/2 A, which is 34, times B, times C, sorry, which is 42, times sine of B, which is 55. Plug it all in, and you should get approximately 585 feet squared.